Seventh graders, let's get started today. We got 5.4. It says to write and solve an equation to answer the question. Number one says, what number is 25% of 64? You know that there's two ways to do this, using cross multiplication or the percent equation. I'm going to go ahead and use cross multiplication for the first one and then percent equation for the second one, so you know both your options. If I'm using cross multiplication for the first one, I have my two fraction. What number is 25%? We know that there's always 100% on the bottom over here. That means 25% has to go on the top because it's the only number that has the percent sign after it, like my 100%. The other one's numbers, and it says of 64. We know the of goes on the bottom, and the is goes on the top. That's right. The of goes on the bottom, and the is goes on the top when we're making this fraction, right? So we're looking for the x. That's going to put us at 100 times x, which is 100x. And then 64 times 25 equals 64. And you know what, just to make this a little easier, I'm going to use my calculator, because we already know that when we're cross multiplying, at least we should know by now, and I'll use the highlighter, that we take the top number times the bottom number of this one, and we make it equal to the top number to the bottom number of this one. That's why we're making this. So 100 times this. Now we're going to take 64 times 25. I'm going to use my calculator. And it says it's 64 plus 25. 64 plus 25. That's going to give us 89. That is not even close to being right. Oh, I said plus. It should be times. I'm sorry. Now let's clear that. 64 times 25. And that's 1,600. And now I know I need to divide 100 away from 100x so I can get x by itself. And whatever I get on do to one side, I do to the other side. So I'm going to divide this side by 100. That's going to give me 16. All right, so 16 is 25% of 64. All right, now I'm going to show you number 3 using the percent equation. Now remember, the percent equation says that the is equal to the percent times the of. All right, either one of these you could have used for these two. So it says of what number. That means we're looking for the of. We'll put x over here. Says 5%, so I'll know that I have to move the decimal over twice. So I'll put 5% first, and then I'm going to move the decimal over twice. And the is number 5. So when I move this decimal over twice, this 5% is going to become 0.05. So everyone see how I moved the decimal 2 spaces to the left, right? 1, 2, and brought it over there. And now I have 0.05x. I'm going to divide 0.05 away from x. And that gets x by itself. I know this because anytime a number is over itself, it equals 1. So since I have 0.05 over 0.05, I have 1x. But whatever I divide from one side, I got to do the other. So I'm going to take 0.05. Okay, and I'm going to take 5 and divide it by 0.05. We'll put that in my calculator, but I'm pretty sure I already know what the answer is. Now I have 5 divided by 0.05. I'm pretty sure that's going to give me 100. Yep. So 5 is 5% of 100. All right, we're going to number 5 now. 5 says write the sum. This time all we're doing is adding these. And my denominators are the same, so that makes it pretty easy. The only thing I have to remember is when I have a positive with a parentheses and a negative, positive times a negative is a negative. So this is really going to simplify to 4 minus 6, or excuse me, 4 over 7 minus 6 over 7. When my signs are different and I have a positive 4 and a negative 6, so they're different, I find the difference, which means I take the big number, 6, I minus the small number, 4, and that's going to give me 2. And then I keep the sign of the big number. The big number had a negative in front of it, so this is going to be equal to negative 2 over 7. And that's it. Now I'm going to go to number 7. I see that my denominators are different this time. It's going to require me to go ahead and find a common denominator. I know I can multiply 4 to 3, and it will get me 12. That will be a common denominator because 12 is over here. But whatever I multiply to the bottom, remember, I'm only allowed to multiply and divide numbers by 1 to keep them the same. So in other words, to keep 3 over 4 the same, I've got to multiply to 3 over 3. That way it's equals the same ratio. 3 times 3 is 9. And now I've got 9 over 12. So this is now turned to negative 5 over 12. Let's see, negative 5 over 12, and we're going to add it to 9 over 12. And once again, I go by the rule when my signs are different, I find the difference. I'm going to take the big number, 9, minus the small number, 5, and that's going to give me a 4. And I keep the sign of the big number. The big number was positive this time because 9 is bigger. So this would be 4 over 12. And I definitely want to reduce because I know both 4 and 12 are divisible by 4. So I'm going to divide the top and bottom number by 4 over 4. Remember, I'm only allowed to multiply or divide by 1. Now I can say that I have 4 divided by 4 is 1. And 12 divided by 4 is 3. So the answer to this problem is 1/3. All right, let's go to number 7. It says you're given a percent of salmon that passes through a single dam unharmed. By what percent does the number of salmon decrease when passing through a single dam? All right, you're given the percent of salmon that passes through one dam unharmed. What percent does the number of salmon decrease? Decrease, okay, when passing through a single dam. These are the ones that get unharmed. So how much does it decrease? All right, so that means the amount that's decreasing is the amount that was harmed. So for 80% here, I know 100% minus 80% is going to leave me 20%. Right? So the amount that it decreases is going to be 20%. And then, let's see. Sorry about that. When we get to number 11, it says 94%. Again, we'll take 100% and we will minus 94%. And 100 minus 94 is 6%. So that means we have 6% that decreased. All right, number 12. It says identify the percent of change as an increase or a decrease. Then find the percent of change. So this is the key words here. Whenever we see percent of change, I'm going to underline it. In fact, I'm going to highlight it. Yeah. Whenever you see find the percent of change, okay? It even says identify the percent of change, okay? Uh, as an increase or decrease, then find it. So is it going up or down, right? Is the price going up or down? And then by how much? 12 inches to 36. Well, this obviously is going up, right? So this is going to be an increase. So I can put increase over here. And then by how much? Well, we got 12 to 36. And remember the formula. The formula is big number minus small number divided by the original number. That'll give me the percent that it's increasing. So I'm going to take 36. I'm going to minus 12 because the big number is 36, small number is 12. And then I'm going to divide it by the original number. It says 12 to 36, so 12 was the original number. All right, 36 minus 12 is 24. And now 24 over 12. And 24 and 12 are both divisible by 12, right? When you take 24 and divide it by 12, I'll go to my calculator again. 24 divided by 12 is 2. So that means the percent of increase equals 2. Okay? But remember, we have to move that decimal over twice to turn it to a percent. When I do that, I just realized I was doing number 12 and I'm supposed to do number 13. Okay, so we're going to go ahead and that was almost a freebie for you, wasn't it? Yep. We're going to go ahead and go to number 12 and I'm going to have to erase this for those that didn't speed through it and watched it. Lucky for you. For those that didn't, but for those that sped through it, you didn't get to see anything. For those that did watch everything, then you know pretty much how to answer that now. For number 13, and that's what I'm going to go to now, 75 to 25. So this is a decrease, all right, because the number went down. All right, and again, I'm going to take that formula, big number minus small number. Divided by original number. The big number is 75. The small number is 25. We're going to divide it by the original number, which was 75. This is going to give us 50 over 75. Now I take 50 and divide it by 75. That's going to give me 0.6 repeating. So this is going to be 0.6 repeating. Now think about it, when you write this out, it's going to be 0.66666 forever. So when I move my decimal 2 places to turn it to a percent, it's going to be equal to 66.6 repeating percent. Okay, round to the nearest tenth. So this is the 10th right here. Since the second one's going to be a 6, this will round up to 7. So when I round it up, it's going to be 66.7%. All right, let's go to number 15. All right, number 15 says 24 songs at 78. That means it's increasing. So I need to remember to put increase. All right, then we're going to work the problem like we had over here. We're going to take 24, so that means it's big number, 78 minus 24 over 24. Well, 78 minus 24 is going to give me 54 over 24. When I pop this in my calculator, 54 divided by 24 is going to equal 2.25. When I move my decimal over two spaces to turn this into percent, that means it's going to be 225%. All right, number 17, 72 to 63. This is a decrease because the number went down. Now we're going to go ahead and take big number, 72 minus 63. We're going to divide it by the original number, 72. Well, 72 minus 63 is 9. And now we have 9 over 72. And I pop that in my calculator. 9 divided by 72. That gives me 1.125. 0.125. Now when I move my decimal place two places to make it a percent, it's going to equal 12.5%. All right, number 19 says 68 to 42. That's a decrease again because the number went down. When I solve it, I see that I'll have the big number, 68 minus 42.5. And we're going to put that over the original number, 68. Now we're going to take 68, and I'm going to put this in the calculator because we got decimals here. 68 minus 42.5. That's going to give us 25.5. Over 68. Now I'm going to take that 25.5 and divide it by 68. That gives me 375, 0.375, 0.375. When I move my decimal point two places to turn it to a percent, it's going to equal 37.5%. All right, let's go to number 21. Last week you finished level 2 of a video game in 32 minutes. Today you finished level 2 in 28 minutes. What is the percent of change? What is the percent of change? Well, the level 2 part doesn't mean anything, but the amount of minutes is what you're counting here. When I look at the amount of minutes, I realize that I had 32 originally, and that is the big number, so I'll put that first. Minus the small number, 28. And the original number, since at the beginning was 32, I'll put on the bottom original. I know this is a decrease because the amount of time went down. So I can say this is a decrease. Okay. And now I just have to say, well, let's figure out the problem here. 32 minus 28. 32 minus 28 should be 4, I believe. Yep. And then we're going to divide that by 32. So now we're going to turn this to 4 over 32. And we're going to divide 4 by 32. And that gives me 0.125. Now to turn it to a percent, we have to move the decimal place 2 spots. That becomes 12.5. So what is the percent of change? A 12.5% decrease. All right, number 23 says a researcher estimates that a fossil is 3,200 years old using carbon-14 dating. A procedure used to determine the age of the object. The research discovers that the fossil, uh, let's see, well, he estimates, estimated 32,000, and now he used this procedure to find out it was 36,000 years old. Find the percent of error. This time we're talking percent of error, okay? And we have a slightly different formula for this. We take the big number minus the small number, and we're going to go ahead and divide it by the actual number. Okay, so the big number, of course, is going to be 36,000. The small number will be 32,000. The actual number, remember, this was an estimate. That wasn't really it. So we got to go ahead and divide it by 36,000, the actual number. And so 36,000 minus 3,200 is going to be 4,000. I'm sorry, actually that's 400, right? 400. And we're going to put that over 3,600. So now we got to take our calculator and take 4,000, or 400, apologize again. 400, and we're going to divide it by 3,600. That's going to give us 0.111111. Okay. 0.111 repeating, right? So when I move that decimal over 2 spots, it's going to be 11.1. So the percent of error is 11.1% error. Well, I should say percent of error. All right. Next it says, what other estimates gives the same percent of error? Explain your reasoning. Well, I got lazy, so I just took this. I didn't feel like typing it all out. I'm not going to lie. Let's go ahead and move this to where it's supposed to go, though. For some reason, oh, I see what's going on. There we go. And we're going to shrink it so it fits in there good. Right there. 4,000 years old says the same amount of error and the original amount are the same, giving the same percent of error. So it says, what other estimate gives the same percent of error? So if it was 4,000 years old, because over here, the percent of error was it being too small, but we could say an increase, right? In other words, adding 400 would also give us that same percent of error. All right, number 25 says identify the percent of change as an increase or decrease. Then find the percent of change, round to find or to the nearest tenth of a percent if necessary. I got number 25 here. We got 4 over 5 to 3 over 5. Well, I know the big number is 4 over 5, right? And remember, we're taking the big number minus small number divided by original number. If I'm going to do this, I'm probably going to use a different technique. There's actually 2 techniques I can use. One, I can turn these both to decimals and then work with that. Or I could just put them in my calculator as fractions and then see how that works. Let's try the first one. I'm going to put these both to decimals. I know that 4 over 5 is 4/5, and 4/5 is 0.8. And I know that's bigger than 3/5 because they both have the same denominator. I'm going by the numerator. 3/5 is 0.6. So I would take 0.8 minus 0.6, and then I would divide it by the original 0.8. Well, I know 0.8 minus 0.6 is going to give me 0.2. Now I have 0.2 divided by 0.8. And when I take 0.2 and divide it by 0.8, that's going to give me 0.25. When I turn 0.25 into percent, I have to move that decimal 2 places. So that's equal to 25%. Right? And because it's going down, a smaller number, this is a decrease. So I could put decrease here. All right, let's go to number 27. I'm going to do it the other way this time with the calculator. Watch how this works. This time, I realize every fraction is a division problem. So I'm going to treat each division problem like a number, but I'm going to put them in the bracket. Watch it. Put parentheses, right? Then I'm going to put 5 divided by 4. 5 divided by 4, and then close my parentheses. Instantly, it turns into the decimal. Now, I have to figure out which one's bigger, 5 over 4 or 3 over 8. Remember, 5 over 4 was 1.25. Now, let's find out what 3 over 8 is. Minus 3 divided by 8. That's 3.75. I'll be honest with you, I forgot what 5 over 4. I'm going to write this down. All right, 5 over 4 again. Let's see. I'm going to go back here and erase this. 5 divided by 4. 5 divided by 4 was 1.25. So 3/8. Oh, this is silly. I know that it's a decrease because 5 is bigger than 4. That was really silly of me. So I'm going to take 5 divided by 4 in parentheses. That gave me 1.35, which is bigger than 0.375 because a 1 is a whole number. Then I'm going to minus, in parentheses again, 3 divided by 8. That gave me, now I got to press equal. The answer is 0.875. That's the top number. Now I'm going to divide this number. Remember, it's a fraction, right? And I'm just going to demonstrate over here. We found this answer, right? And they told us that it was 1.25, I believe. Right, and we minus, I believe, it was 3.7 or 0.375. We put that over the original one, 5 over 4, which is 1.25. And we're back over here at the calculator, right? We had gotten 0.875, so let's just turn this over here to 0.875 over 1.25. I'm not sure about this number now. I have to double check this one. But then we're going to divide it by 1.25 again. And that's 0.7. So when I move my decimals 2 spaces, this will become 70%. And since the number went down, we know this is a 70% decrease. All right, I'm going to double check this 3 divided by 8 because I think I might have messed up there. 3 divided by 8 was 3.75. And let me double check this one more time. 1.25 minus 0.375. Yep, 8.75. And then divided by 1.25. That gave us 0.7. Yep, I did everything correct. So that was 70% decrease. Let's go ahead and go to number 29 now. It says the table shows population data for a community. I might have, oh, this must be it here. It says from 2014 to 2020, this definitely is it. All right, what is the percent of change from there to there? All right, so if I do the percent of change, remember it's big number, so that's this one. Minus small number. And we're going to divide it by the original number. The original number was 2014, so this would be 118. We know this is going to be an increase. Let's just use our calculator to make this easier. Let's see, we're going to clear this. We got 138,000, excuse me. And we're subtracting 118,000. That's going to give us 20,000. So I'm just going to write that in real quick. This equals 20,000. Divided by 118,000. So I'm going to take that 20,000 and divide it by 118,000. That gives me 0.1694. 0.1694. And some numbers. When I move the decimal over 2 places and then I round up, this is going to be 16.9%. So the percentage change is 16.9%, and that's going to be an increase. All right. I guess I should have wrote that whole thing out. It would have been easier, huh? 16.9% increase. All right. This was kind of sloppy over here. B, your friend predicts that in 2026, the population would be about 161,000 people. Is your friend's prediction reasonable? Well, what's that going to be the percent? Remember, he's predicting it. That's not what the actual amount is. So we're going to have to take 161, the big number, minus, let's see, well, I guess what it is in 2020, which would be, let's see, your friend predicts the population will be about one. Oh, I see what they're saying. What they're saying is, yeah, let's erase this. They're not looking for the percent increase. What they want to know if every year, and remember how many years went by here, 6 years, right? So we're going to take 16.9 and divide it by 6. Divide it by, see, yeah, 2014, 15, 16, 17, 18, 19, 20. Divided by 6. That gives us 0.0282. Now, the reason we're doing this, remember, that's telling us every year how much it increased, right? So they're saying in another 6 years, it's going to go up by that amount from what we are here at 138,000. So really, since this is a 6-year increase and this is a 6-year increase, I could just take that original amount, 16.9. I'm going to take, let's see here. I'm going to take the 20,000 I had, 20,000, and divide it by 118,000. That gave me my answer. Now I'm going to take that, since it's already in decimal form, and I'm going to multiply it to the amount that I have here times, oh, wait a second, this is an increase, right? Not a decrease. So let's see here. We're going to have to add this amount to that once we find it. So we're going to multiply it to, remember MMA is move it, multiply it, and right now we don't really need to move it because it was 16.9%. So now we're just going to go ahead and multiply this. And we're going to say times 138,000. That's going to give us 23,300 and whatever. And then we know that's going to average up because we're talking people. We can't really go ahead and have all those little decimal points. So probably put it to about 23,390. But now we're going to add this, okay, to 138,000. That gives us 161,000. I'm sorry, my mouse seems to be froze up here. Quite no, there we go. There we go. I had to adjust the computer for a second. That gives us 171,000. Let's move this out of the way. 161,000, that's what we had here. 389. Yeah, so that's really close. So he's only off by about 400, right? He says about that. So I would say, yes, the prediction is reasonable. I think we said he was only off by about 400. Let's look over here. Yes, by about 390. All right. Oops. About 390 people. All right. Let's see here. All right, so let's move on to number 31. All right, it says a company fills boxes with about 21 ounces of cereal. The acceptable percent of error in filling a box is 2.5%. Box A contains 24.4 ounces of cereal, and box B contains 21.5 ounces of cereal. So one's a little less, one's a little more. Tell whether each box is the acceptable weight. I'm going to be honest with you, I didn't feel like writing all this out. So I'm going to pop in these answers here that are already pre-written. And then I'll show you how you got it. We see here that we have box A. Remember, we're going by the percent of error, right? Percent of error. And we have the original box. We know that we want them to be 21, right? So we're taking 21 in the first box and minusing 20.4. And that's going to be a difference of 0.6. And remember, the actual box should weigh 21. So it's 0.6 divided by 21, which gives us 0.029 when I move that decimal 2 places. That's a 2.9% error. And the only acceptable error is 2.5. So that's too much. Box A is unacceptable. Box B, on the other hand, is 21.5 minus 20.4, which is only a difference of 0.5. Okay? And when we do that and divide it by 21, we see that we're going to have, I got to say, it's 2.5 this. So you're only over, 21 to 21.5 is only a difference of 0.5. When you divide that by 21, you get 0.024, and you move the decimal over 2 places, that'll be 2.4, and 2.4 is under 2.5, so box B is acceptable. All right, let's go to number 33. Says a number increases by 10%, then decreases by 10%. Will the result uh, be greater than, less than, or equal to the original amount? I can tell you that it's not going to be the same. So let's pop in the answer so I can explain it to you. And I know this video is getting long. That's why I'm trying to do a little quicker so you don't have to watch me write. It's going to be less than, not the same or greater than, because remember, let's let X represent the number, right? So we have a 10% increase. And so we're taking X and we're adding it to 0.1, because remember 10% when we move it, sorry, we have 0.1, we move that decimal point twice back, it's become 0.1, right? And so that's 0.1x. And that's going to be, when we do that, that'll be 1.1x, right? So the percent of increase, right? It says first, a number increases 10%, then decreases, right? So when we increase it, it's going to be 1.1x. Then we take a 10% decrease of that new number. Now we have 1.1x. We're minusing 0.1, right? That 10% again. And 0.1 times 1.1x, that's going to be 0.99x. Because 0.99x is less than x, the result is less than the original number. So when you do that, you're going to be taking a bigger amount away. So yeah, you'll end up with a less than. Number 35 is the last one. It says 40 students are in the science club. Of those, 45% are girls. This percent increases to 56% after more girls join the club. How many more girls join? When I work this out, I'm just going to say that 40 students, if I got 40 of them, and I want to know how many 46, I would multiply that to, remember, this is the percent equation is, right, is going to equal the percent times the of, right? Percent times the of. And let's go ahead and break this down over here the way it's written in our problem. We're going to have, we're finding out the is. We know that there's 40 kids in the club. We're taking 45% of them, so that'll be 0.45 that we multiply this to. 40 times, let's see, 40 times 0.45 is going to be 18. So there were 18 kids, girls in the club already. And now we're going to increase it by saying 56% more join. So now we're taking the amount, right? And then we're multiplying it to, let's see, I'm going to move this over, 18. Putting it right back in here. 18 this time is our original amount. And then we're multiplying that to 0.56 to see how many more joined. Right? So we're looking for x here. And we take that 18 and multiply it to 0.56. We see that 10 point, well, there's no such thing as 0.08 girls. So 10 girls, right? So 10 girls joined, right? How many more girls joined? 10. All right, that's all of it. That was quite a long video, so let me cut this short. See you in class for grading. Good night.